Today we're going to start with 9.1, product, power, and expanded power rule. So first we'll talk about product rule. Product rule states when multiplying with the same base, you will add the exponents. When multiplying with the same base, you will add the exponents. So an example is that x to the power of m times x to the power of n, because they have the same base, we would say that x could be simplified as m plus n. Okay, so now we're going to do examples. Number 1. Now we're going to start with bases that can be numbers or variables. So 3 squared times 3 cubed. 3 squared times 3 cubed. So based off this logic, they have the same base. They're both 3 on the base. So therefore we can add the exponents. So 3 to the power of 2 plus 3, which would simplify as 3 to the 5th power. Now, because it's a number base, we could simplify this by actually figuring out what that number is. Now, when something is to a power, that means you multiply the base by that many times. So it would be 3, excuse me, 3 times itself 5 times. So 3 times 3 times 3 times 3 times 3. But in this case, using your calculator helps. And all you have to do is 3, and there should be a function where you power 3 to the 5th power, which is 243. Number 2, negative 5 to the 1st power times negative 5 to the 5th power. Now, normally we wouldn't have a 1 here, but if it wasn't here, we would treat it like such. So we have negative 5 as our base, 1 plus 5, which equals negative 5 to the 6th power. And we would use our calculator and our parentheses to help us out. So negative 5 to the 6th power would equal 15625. Now we need to use our commas. So commas are in groups of 3 starting from the right. So this would be my first comma. So this number is 15,625. Okay, now I want you to try number 3 and 4. Two cubed times 2 to the 4th, and negative 4 squared times negative 4. Go ahead and try that one now. So your work should look like such. 2 to the 3 plus 4th power. So 2 to the 7th. Use our calculator. and we get 128. Over here, remember anything without an exponent is technically with a 1. So -4 to the 2 plus 1, so -4 to the third power. And when we use our parentheses and our calculator, we get -64. Now, why did this one become negative and this one didn't? Well, it's based on how many times you multiplied. So we know that a negative times a negative is a positive. Well, a negative times a negative times a negative would be a negative answer, hence what we get here. Now we're going to do variables. Same concept. X to the 9th times x cubed. So they're the same base, so we add them. X to the 9 plus 3, which would be x to the 12th. Next one, y to the 7th times y to the 6th. Again, same base, so we add. So y to the 7th plus 6 equals y to the 13th. Number 7, w to the 12th times w to the 33rd. Now at this point, I hope that you don't necessarily need to put the plus symbol, but you can still keep doing that. So you could also think, well, it's going to be 12 plus 33. So 12 plus 33 is to the 45th. Let's try number 8. 2 squared times x cubed y squared times 2x squared y to the 4th. Okay, now again, remember anything without an exponent technically has an exponent of 1. So therefore, if we're adding 2 plus 1, this would be 2 cubed, x cubed and x squared. 3 plus 2 will be x to the 5th, and y squared and y to the 4th. 2 plus 4 would be y to the 6th. Now again, because this is a number base, we would evaluate it. 2 times 2 times 2, which would be 8, and then x to the 5th, y to the 6th. Number 9, 4y times a squared y cubed. Now, the 4 doesn't have anything to multiply with, so it just stays there. Now the question is, which variable goes first? So the rule is alphabetical. So technically, a should be written next, and nothing can combine with a. And then y, remember y would have a little 1. So 1 and 3, so y to the 4th. Okay, so I'm going to leave you with number 10 to try on your own. Okay, and I'll be back to check on number 10.